Hi guys, this is a Debian Science BoF, registered by Anton Gladky, Alastair McKinstry, and me, Andreas Tille. And Anton will now show a few slides for an introduction, then we can discuss some issues.
Yeah, hello. Hello everybody. My name is Anton Gladky, and I would like to make a very, very short introduction into this Debian Science BoF. First of all, a couple of words about me. I am working at the Technical University Freiberg at the Institute of Mineral Processing Machines. And part of my work is that I am doing some numerical simulations based on particular based methods. And for my work, I need an open source software, and that is why I'm connected to open source software. Yeah, and let's see a couple of slides about a Debian Science team. As it's seen from the name, it is mostly about science software, not only science software, but some of software is related to the science. And we are a group inside of Debian. We are not an independent part. We are part of Debian. And first of all, we have two mailing lists for the communication. The first one you see here, Debian Science maintainers at allowed lists Debian.net, where mostly maintainer questions are raising up and are discussing. And the second list is mailing list, more general. It's Debian Science, where more general question can be asked and answered. Also, we have a Salsa group. It's GitLab-based software where most of our packages are placed and maintained. So if you want to contribute, feel free to join this group. And we have about 190 users at the moment, and we have over 1,000 packages there, or at least projects there, which are related to the science team. Also, we have a Wiki page. It's not very frequently updated, but it's possible to use it and to get some information about subgroups in our team. Also important that we have so-called Debian Science policy. It's not very strict, but some general rules are placed there, how you can add your package into the science team, how you can maintain it, what should be done in the package to be accepted by Debian Science policy. And I have found that the first commit into this policy was done about 12 years ago. So we can say that the science team is about 12 years old. So as we are a science team, I would like to show a couple of statistics about the team. First slide is showing how many packages we have per release. And the statistic I started from Jessie release, which was done in 2015. So we had about 388 packages. And then we had a large jump for about 300 packages between 2015 and 2017. It's about 300 packages. And after that, we have a growth about 20 packages per release. It's not large, but I think we are more or less stable, and the team is growing slowly. The next statistics about number of uploaders per release. So how many people are involved in this team to contribute into the software, scientific software. You see also that there are some jump between Jessie in 2015 and Stretch 2017. It's about 40 people, and after that we have about 20 people more in each release. Yeah. So this is the list of some packages, which is packages which are having the highest popcorn values. It's not always very good number, but at least you can see that most of packages are libraries. It's some mathematical libraries, linear algebra libraries, and some, for example, OpenCV. It's for computational vision library, and many others which we are maintaining in the team. Also, we have a software like For example, FreeCard and ParaView are maintained also in this team. Yeah, and the last statistic page is about how statistic uploaders and packages. So it means every member of science team have a particular number of packages. And as you can see, some people are having over 80 packages which are maintained by them. It's a really huge number. And some people are having less packages, but at least yeah, it's relatively large. So it's almost everything from my side. I think Andreas will continue with the statistic and we'll give some more information after his talk. Andreas?
Yep. Yeah, I just switched my microphone online. So here you see who are the members of the Debian Science team, or at least 10 most active members. You see those people who have uploaded over the years. You see since 2000 there are some uploads, and the uploads became more in the 2014, 2015. And we have quite some peak here. This is not really, yeah, this is not very astonishing because we changed to Elliot, so this is an artifact in this statistics. We have discussions on the Debian Science user mailing list. There are other people discussing than uploading, which is fine since we also have users who are interested in Debian Science. We have a developer mailing list, which is basically synchronizing uploads and bug reports in one graph. And we have people who are hunting bugs, thanks to Anton, who is hunting the most of the bugs, and other people are contributing as well a lot. We have commits to our Salsa instance, which are also graphed here. It is basically reflects people who are doing the uploads. And the good thing is that we have kind of a solid base of people who are keep on contributing to the team. And there are other teams which have single peaks in single years, and then people are going away. Yeah, this is a graph which represents the number of people who are committing to a package. And in my opinion, this is this shows a worse situation, because you see the majority of package is maintained only by a single person. And the optimal graph would like here 0 here, increasing, and then have a curve like this, because having only one maintainer per package means we have a very bad run over by bus factor in the Debian Science team. So it would be great if more than one people could commit to one package. Well, this is actually all I wanted to present, and I now hand over to Alastair to continue with his short intro. Your mic is muted. Please unmute.
I pressed the button twice too fast. Yeah, apologies for not preparing for some slides for this. We are. I think the package, the statistics are good. I think we have a slightly misleading in that there was also there was a significant overlap today with other teams, with the Python and with the HPC teams, which a bunch of the packages are not listed under. And you know, there's a lot of shared shared work across all of that work. For example, a lot of work has gone recently into providing Python interfaces to all of the code and licenses within the meteorology community. And so all of that packages are typically stored under Python packages rather than under science. But this is more a terminology issue. We have a very active science group within both of those. And I think that from my perspective, I should say that one of the key bases is I'm a HPC developer working within the weather and meteorology community. So we have a shared, one of the sets of licenses that are not showing up well in the science group is the MPI, MPitch libraries to try and make those scale, which would be the kind of key part of of some of the work which I would be doing. And so I would like to see, coming from the discussions, from our discussion today, how people think that should work. So we have a lot of, what kind of things should we be doing in the Debian science community, to push the usage of Debian science in our communities. For example, I'm in the HPC community. Debian is increasingly used in containers, and so containerization is going to be important, particularly with Singularity, where it was only used before mostly on laptops. So, I mean, for my case, for example, we run the High Performance Computing Centre of Ireland. The operating system that gets used for most of our work is not Debian, because we need technical support from a commercial vendor for the large machine. But most of the work that gets done on the post-processing and by the individual users is Debian, and so the interoperation between those becomes key. And it's kind of, I think it's going to be important for us to work within, but increasingly that's changing as we move to containers, and we can run Singularity and Docker containers within our HPC systems. And I think it's going to be important that we figure out how we develop, we work towards that end. Okay.
Thank you very much for your interesting information. I think we can, if you have online users, we can provide them a link to the other part. So if you have a question, feel free to add your information into other part, and the link you will find on the page of DebConf, Debian Science BoF. Okay, I just wanted to say a couple of words about how you can contribute and how you can join the Debian Science team. Most of people are coming because they have a software and they want to have it uploaded into the archive. And in most of cases, they just upload their package into the mentors Debian net, and they just drop a message into the one of mailing lists and asking for a review and for sponsorship. And in most of cases, it works very good. So if some Debian developers are finding the time to review the package and give a feedback, or even upload the package without any questions, it works. And so people can join group and it works. So Alastair, do you have any questions from users right now?
I would like to comment a bit on Alastair's statement that the packages are also partly in Python team and other teams. From my perspective, the Debian Science team has just those scientific software which is not put somewhere else. For instance, in the Debian Med team, we have a lot of biology software which is better than the Debian Med team. In the DebConf team, they have chemistry software which is better maintained by chemists, and we have also Debian astrology. And if there is a good reason to put a Python library under the control of a Python team who they are the Python experts, that's perfectly fine. So the Debian Science team is not fighting to get packages, but not trying to care for what's not properly placed somewhere else.
I agree. I think the Python one is a good example because there are interoperability standards are very key there as to where we measure it. I think more important probably will be the HPC packages, which are for me key underlying large scalability for science software. How we make that work. So that's increasingly key for containerization, but also the number of packages that will work on a multi-core HPC machine is simply growing. The expectation that that this is a unique thing, that a machine is multi-core, is disappearing. And the expectation, so the number of packages, for example, there's a package MetView, which is a visualization package for weather codes that will now work with MPI, and so will scale across large numbers of cores. We need, that will work and will be maintained within within Debian Science, but how that works across multiple cores, and how we test all of that is going to be a challenge. The number of multi InfiniBand systems, etc., becomes a challenge to test with. The HPC systems are relatively few of them use Debian, but that's going to be a core for a large number of the key Debian Science packages. How we test out when we get to at larger scale. That's going to stretch our infrastructure problem questions and testing infrastructure, I think.
Yeah, I fully agree about this. Another example is the LAPAC infrastructure, which was done by Mozo in a Google Summer of Code project. I just invited him in this BoF. I hope he might join. This is a similar topic. And what also happened, because Python was one example, and we have a lot of stuff in R packages. So we merged all the R packages from Debian Science, Debian Med, and DebConf into one R packaging team, because it's extremely easy to synchronize everything at one place, and there is no point in maintaining it in Debian Science.
Just saw a question coming in. Are the Debian Med and astronomy teams sub-teams part of Debian Science teams? Are there any plans to bring them into one roof? I think the answer is that they are sub-teams, and that basically it's interoperability is the key, and maintenance is basically the key issues. And can you comment? But I think it seems to be working okay.
Yeah, I think, well, a lot of people of the other scientific teams are reading the Debian Science mailing list, and you are a team member when reading the mailing list and commenting on it. So there is, I think it's quite good networking between those teams on the Debian Science list. And this was the actual purpose, to find common issues of scientific teams and discuss it there.
I think we have one more question about IMD 64 packages from Wiki. Wiki, are you able to say something?
Yeah, it's now.
We can't understand you. It's really hard.
Am I sounding terrible? Is it better if I turn the video off? Is that any better? Does that make any sense? Hello? No?
Could you please repeat your question, because the connection is not quite good and we cannot understand what you're talking about.
Okay. I don't know if I can easily improve the connection except by talking slowly. Is that better? No? Can you hear me?
Perhaps.
Not really?
Yeah, I think so. I think so.
Just to say that ARM64 is now more important in science stuff, and there's hardware acceleration, and I'm available to help get ARM64 support in packages which currently have it turned off. There's a lot of things that are x86 only. Sometimes there's a good reason, sometimes there isn't. So yeah, I would like to help make some of that stuff. I noticed something last week that wasn't, just has ARM64 turned off for no good reason I can see. Maybe if things are slow, if there's explicit accelerations missing, and also connecting to hardware support for acceleration. The ARM-NN got loaded recently for the machine learning part in the ARM compute library. And working out how to connect that to the back ends of things so we get proper acceleration is some work. Does that make sense?
I'm sorry, I cannot say if it makes sense because I got too less information from your speech.
Well, never mind.
I just understood machine learning, and we are doing something about machine learning, and we try. The only thing I know what is currently doing is what we are currently doing is this SIMD support, and it's basically in the Debian Med team. I think you joined the Debian Med BoF yesterday, or you can review it if it's online. And this is what I can say about ARM64. I'm personally not really good informed about this status in general.
I think it's key for us with machine learning and increasingly with the weather codes where we're increasingly using non-standard double precisions. So we're going basically a lot of work going down to single precision, half precision, and variable precision. 3 or 4 bits even for some certain variables. And the ARM64 architecture has specialized hardware for scaling the SIMD operations on non-standard and smaller precisions, which is going to be key. One of the reasons why there's been a renewed interest in packaging a new Fortran compiler, Flang, has been that compiler came from PGI because the G-Fortran compiler was optimized for x86 only. And so as the new, originally Mont Blanc HPC computer based on ARM and new hardware based on the Cavium, etc., will need better support for ARM processors going forward. And that's going to be key. So how we handle mixed and non-standard precision is going to be a challenge, I think, with LAPAC, with the machine learning, and with a lot of the underlying libraries.
Hey ho, I've just switched to Chrome. I don't know if I'm any more comprehensible now.
Yes.
It's much more better, thanks.
Okay.
You can,
right.
you can hear you.
Blame Firefox for
So
being
please
shit.
repeat.
Yeah, so sorry, I just said I switched to Chromium to see if you can actually understand me.
Please repeat what you said. Now we have a real chance. It was interesting, I assume.
Okay. Yeah, sorry. Yeah, so basically, obviously ARM cares about ARM64 support for all this science stuff. And I hover on the edge of the science team. I've helped package a few things like the cave surveying stuff and Mesh Lab. But anyway, I can spend time on trying to make sure stuff is enabled for ARM64 and we're actually connected to hardware acceleration and backends and whatever's necessary. Quite a lot of things have ARM64 turned off. Well, everything except x86 turned off. And sometimes there's good reasons for that and sometimes there aren't. So I'm keen to enable more stuff, and obviously there's getting it working and there's getting it working at a useful speed. And those aren't necessarily the same thing. So yeah, please pester me, and I'll pester you people about. I think libinsight toolkit 4 I noticed this week isn't enabled, and it builds and seems to pass most of the tests. One failed, so we should probably just turn that on. But I don't know whether in fact some things will be incredibly inefficient, for example, without specific accelerations.
It may be important to do profiling and tool support on ARM64. That would be slightly different.
Yeah, I'm sure there's lots of stuff that will build, but only run incredibly slowly.
Yeah, and that there will be a testing against all of that and making sure that that works is going to be a challenge.
Yeah. Okay, so yeah, that's all I really had to say. Hi. I'll try and get a bit more involved. As I say, I hover on the edges of this team, but occasionally do something useful. But
I, from my perspective, can say, well, we try really hard to have auto package tests on all Debian made packages, and auto package tests are also run on ARM, and in most cases this runs smoothly. In most cases, there are some cases where some floating point numbers are compared and not for this. The restrictions are set to dense and so, but in most cases it's working. But I will now learn the lesson that if we have some problems, I will ask you.
yeah, that's a good start.
Good. It's nice.
Okay, thank you very much for the information, and I hope you'll be able to contribute to our team, to science team as well. Thank you. Okay, I have some more information to discuss. It's about Salsa and continuous integration. As you know, at the end of 2017, we had a large migration action, and we have migrated almost all packages from Aliot to new Salsa server. So it's a GitLab server, and almost all of packages are already in Salsa, and it worked very well. And a couple of months ago, so I'm doing this work really in free time, so I do not have too much time. And that is why I started to add continuous integration tests into some of packages which I maintain and packages which I am plugin or sponsoring. And I find it very, very interesting and very useful because this auto package test and different tests which are already implemented in Salsa CE are really good, and they can find a lot of interesting information and a lot of stuff to be fixed. And I propose that many people are trying to include these Salsa CE scripts in their packages, and thus you can make the quality of your package higher, and you can see whether the package broken or not. The only problem which I see is...
For the CI, if I'm not misleaded, every repository needs to have a switch that Salsa CI should really run. It's not sufficient to add the Salsa CI YAML file. It is correct.
Well, in most of cases, you just need to add this Salsa CE file into your repository, and sometimes you need to change the settings in your package, and that's it. And then you can change. In
the package or in the repository on Salsa, but because I have the impression that I'm adding automatically this Salsa CI YAML file to every package I upload, but the Salsa CI is not running. I need to.
Yeah, you need to change the settings, because I think there's you need to change the default place for your Salsa CE YAML, and it works. But we can discuss it later. So I can just show you how it works, and it works. But it's not the main part of the work. You need to see whether your package is running on Salsa CE, and if it is running, it's fine. You need to do nothing. You can be sure that your package more or less fine. But in most of cases, you need to make some fixes in the package. Maybe lintian warnings or errors need to be fixed, or auto package tests are not running. It is checking whether the package is binary reproducible. So if it's not, and it's also failing, and there you have two options: whether you fix it right now, or you're just skipping this test for the moment and hoping that sometimes it will be better and it will pass the test. So it's just the common information for the science group and maybe for other med group. I find it very useful, and it can increase really the quality of packages, and we'll get less failures in compilation. The only problem which I see for our scientific packages is that some of them are really large and they require a lot of time to be built. It's, for example, like VTK packages that taken hours to be built, and At the moment, it's we have a limit about 1 hour on the SASA CE, so I think we need to find a solution for these large packages, maybe by installing some builders, external builders, where it will be possible to build such large packages somewhere externally.
But in theory, you can just increase the timeout, right? At least for one package. I mean, you're allowed to increase the timeout. You just are not very nice to the other people because you take the resources.
Yeah, that's true. Yeah.
So yeah, I guess having a dedicated Debian Science runner or runners would be a great thing. Maybe we can get some sponsorship for them for getting these really large, because I'm also running into those problems where 1 hour is just not enough for my packages. So maybe we could get some sponsored runners somewhere where there should be some companies maybe or institutions interested in doing this kind of thing.
We could. I think it would be useful to do that, particularly for MPI testing. We are one of those areas where we are a very useful test for the underlying library through upstream because of the scale. So, for example, MPI has one of the best build test infrastructures out there in the collaborative world for an open source project, but we are very useful for them because we test we test stuff that other than x86 and potentially ARM. So we find a lot of bugs that are 32-bit based or endian based or code weaknesses as they come through. And compiler issues are coming through, but we lack the ability to run those across multiple cores. So trying to find architectures where we could do testing, HPC type architecture, so we can test the full science stack would be very useful. Potentially useful for our company, for money. We can do more of this if we have a strategy for containerization. Personally, I'm working a lot with Singularity. So our machine that we use is our HPC machine, the petaflop machine at work, is Red Hat based as an operating system, but we can run Debian codes within a Singularity container and then scale them, of course, with MPI. And I think we will see a lot more of that happening in the future, where people develop their codes on a laptop or small their own build machine, and can use Debian there, and then strip them to large computers or other scalable computers as containers. And I think we may see more science codes working that way. To my knowledge, only CNOS and France are the only people using Debian on large scale on HPC machines. There's a small handful there, but other than small departmental clusters in universities, etc. But I think we will see a large scale up over time because the software stack is becoming so complex. And if we pre-build a lot of the software stack, that will be very increasingly valuable. So within work, for example, we will maintain the software stack of about 10 or 20 main libraries. But if you're building other codes, there's increasingly a very complex stack of 20 or 30 libraries with variants on builds that are compiler dependent, that shipping a standard container based on Debian that people can build their own application on, and then run it on a large HPC machine becomes very important for their science purposes. Yeah.
Okay, thank you. Do we have some? Yeah. Do we have something else to discuss? I'm seeing there some information about. No, So there are some questions.
I think Luminous joined the channel, but he is muted. Maybe he can say something about his Google Summer of Code work. Lumin, in case you are saying something, you are muted. You need to unmute your microphone. Maybe.
Hello? Hello? Can you
Yeah.
hear me?
Yes.
Yes, we can hear you.
Okay. Actually, tomorrow I have a short talk about deep learning and some scientific computing libraries such as LabPack. So we can talk about it tomorrow.
Okay, that's fine.
That's good.
Yeah, but good to have you on board here.
Is anybody else doing container work? Or working within Debian containers, or deploying within containers such as Singularity?
No, I don't do this.
Okay.
Okay, do we have something to discuss? Are there any questions?
One question I would have is maintaining multiple versions of libraries, and it'll be interesting to hear Lumen's talk tomorrow on LabPack and how that works. We have a challenge, for example, with running different versions of NetCDF, which is, the difficulty there is that there's different functionality provided by different variants of the package. And no one version at the moment can provide all the functionality. The compressed file format, so compressed file version is incompatible with running it in parallel. So we have two separate builds of the libraries. The trouble is with this is you end up with an exponential explosion of software packages. Now, I've been building a test example of how to work with this within NetCDF parallel, but we're going to encounter a similar issue with the Fortran libraries because they have a different ABI. Has anybody else encountered this problem, or should we document the best answers we have at the moment?
I think that topic was discussed on every Debian Science BoF I remember. It was discussed, but we never found any solution in the Debian universe. Yeah. People say refer to environments modules or something like this, which is
yeah, I've been using environmental symbols, variable method symbols within the libraries. Particularly because when you get to something like PowerView, you end up eventually using both sets of the libraries in different plugins, and so there's the namespace collisions, and so the only way of merging them back together is using the symbols. But eventually, that requires upstream support, and we need to work on a common policy on that, I think.
But you now are popping up another question in my mind, which is somehow related. Rebecca this day asked on the mailing list about Pandas, Python Pandas. We can upgrade to the latest upstream version, but we will break 3 or 4 leaf packages. Would you share my opinion that it's better to take the latest upstream and fix those leaf packages, even if we don't know if we can fix them finally before the release, but then we just lose some leaf packages, but have the up-to-date libraries? What do you think about this?
I would agree with that, because a lot of our users actually use unstable and follow unstable, particularly for science development. And just one of our most useful cases is that we become the integration test bed for testing. So we find those bugs.
Yeah. So I think, Rebecca, because you are also in this BoF, just go for the latest upstream, either 1.0, which you have packaged, or 1.1, which you intend to package, and then we need to fix what needs fixing.
Yeah, I'll give it a try then. Yeah, Sorry, I thought the discussion before was about different options like enabling and not the parallelism that changes the ABA, whatever, and not about versionizing actual different points in history. Which is why I suggested we should use a different word for that.
Yeah, I simply think we cannot use some broken leaf packages as an excuse to ship old software. This is either we can fix it or they are possibly not worth fixing.
NumPy seem to pretty much ignore it and break a pile of stuff. As do a lot of interpreted language packages. The transition process seems to be de facto compiled stuff only, even though when I actually asked release team, him said it's not supposed to be.
Yeah. But in any case, thanks for working on this and all your effort to check everything. And so, are you using this? What is this? Check all these things, or what is this? There's from Paul Weiss a script which rebuilds all dependencies. Are you using this?
No. I think I have my own little script just run through all of Pandas dependencies. There's 50-ish of them. Maybe a day.
But maybe you just check. I forgot how it's named, but there is some package.
Break all the things.
Yeah, build all the things. Yeah. This is doing exactly what you need to test new versions. It's a solved problem, I think.
Dear all, we have only 2 minutes left, so I think we need to summarize our meeting, our talk.
Okay, can you put this in Etherpad, this break all the things? To make sure that it's conserved, because it will vanish when we leave this room.
So there's some more question about Fortran policy. Is anybody working on a Fortran policy for placement of Fortran 90 modules, or do we have them already? So somebody
I have a
Okay.
Yeah, I can. I've been doing that, and also patches to make interoperability between G-Fortran and Clang.
Okay. Thank you very much. We have one more minute, so I just wanted to summarize. It's very good that so many people participated here, and thank you very much everybody for the participation. If somebody wants to join the science team, you are always welcome. We are almost a conflict-free team. We usually don't have any problems, and I hope it will be in the future exactly the same. Thank you very much for information and for your participation in this BoF. And maybe see you next time offline, face to face.
Yeah.
Okay.
Thank you. Bye.
Thank you.
Bye-bye.